Okay, looks like I am live on Twitch. What I'm going to be doing in this particular session is creating or recreating a synthetic data set or a synthetic version for this paper here. So for this paper here, it's recently published oxytocin paper on the effects of oxytocin administration on receiving help. Done by Josh Woolley and co-authors. If you're curious as to what I'm actually doing, be sure to also check out the link on the bottom right of the screen when it comes to the overall paper. But in short, what I'm going to try and do in this session is this particular data set, unlike most oxytocin research, is actually open. So what I'm going to do is I'm going to look at this open data set and see if I can recreate a synthetic version of the data set, which will have the same properties and same relationships between the variables, and I want to see whether I can actually recreate a synthetic version of this and see how well it performs. Okay, so for this particular paper, here's the actual paper here, and then we have the data. This is fantastic. We have both the R script and the actual data set. So here's the R script, so we can follow what the researchers did and makes my job a lot easier because there's no guesswork. And then we have the actual data set here, which is fantastic. This is really, really good. So looking through this R script, the other good thing is that when it comes to actually validating the models within the SynthPop package, it is best if you're working with a linear model. And there seems to be quite a few linear models here, and one in particular which has caught my eye is the effects of observer ratings. So I'll go back to the paper here and look at the results. We observed significant interactions between OT, oxytocin, and the help manipulation. Further, outside observers rated participants who received OT administration as expressing greater happiness and gratitude in response to help. I think that's the outcome, relative to those who received placebo. Good thing is, I had a quick look at this paper beforehand, and the results and the methods look fairly straightforward, which is always a good thing. There's no need to make something more complicated than need be. Okay, so the observer rated effect is what I'm interested in here. And what I pulled out, or what I'm pulling out, is these interactions. It's important to note that these effects are qualified by interactions with oxytocin, gratitude, and happiness. Okay, so what I've done is I've clear this. I've got this this trust data, or this data set. Willingness to help, that is. Importing it. Because it is a large data set with a lot of values, which is a good thing, just to make things a little bit more efficient, I've created a smaller data set with only a few variables, or the variables of interest. These were picked from the code, because these are the code, or these are the variables I'm going to be using. The outcome measure is the happy observer rating, and we're looking at emotional condition and drug condition. Drug condition is obviously whether they received oxytocin or placebo. So the first thing, obviously, is to recreate. First we'll create the synthetic data set. Okay. I forgot to taking a while because it's creating a synthetic dataset for all the variables, which we don't want in this case, but we'll wait for it to finish. Or I'll just stop it. Okay, I've stopped that. Now it's a bit smaller. Now we'll run it. Okay. Just checking that the stream is working. Because if not, yeah, it seems to be working well. Okay. Now let's compare. This is generating the plot. Zoom in a bit. Okay. Yeah. So the happiness ratings seem to be on a scale of 1 to 5, 1 to 4, 1 to 5. A fair bit of missing data as well. But the missingness percentage and all the responses seem extremely similar, which is good. I think there's one more. Yeah. Pretty good. Now, this is directly from the code. Here. So this is for the happy. Where does this match? 3.73. Okay, so there is the interaction on the border of significance if you're using a threshold of 0.05. Yeah. That's for happy, so that's exactly the same. And we'll run the grateful. 0.04, 0.432. Yep. All right, cool. So those are the same. Now that we've done that, I'm going to copy to see how well the equivalent synthetic linear model works. Run that. So this is the linear equivalent, 0.04, 0.43. 32, 160. It's a comparison between the two models. Two. 0.04. Okay, so this one is the equivalent. So now we can take that. I'm going to steal some code from what I've done previously. Call it help. Help sin. And we'll adjust these variables. Paste them in directly. Make them a bit neater. Drug condition, emotional condition, drug by emotional condition interaction, data, HStat. Let's confirm we get the same. Yep. Let's create the synthetic version. Data, we'll get the synthetic data. Yep. So the equivalent one is similar-ish. Let's compare it directly. Compare object against HData. How are we looking? Not too bad. Not too bad. So the synthesized drug condition by emotional condition interaction was not significant, whereas the observed was. It doesn't matter too much because the overall direction seems to work the same. The effect of drug condition is similar and emotional condition is similar. If we look at the actual statistics, So the p-value is non-significant for the differences between results. The confidence interval overlap 0.76, not too bad. Pretty happy with that. I want to make these plots a little bit nicer. But nah, for now I'll leave them like that. Let's do the same thing for happiness. Effect for grateful. Linear effect for happy. Copy and paste. I know there's a quicker way. I don't have the time to find out how to do that. There we go. There. Is it called Happier? Yep. There. So this should be the equivalent of the other one, which it was, on the border of significance to replicate the F statistic. I'll bring this down. Gee, this is a bit of a mess, but I'll have to fix it later. So this is the main reported outcome here. F statistic of, for the interaction effect, 3.72 with an equivalent P of 0.05, 3.72. Let us remember that. The t-value is obviously different, but the p-value is the same. But in order to replicate the F statistic, then we run the ANOVA. 1.9. No, it's different. Oh yeah, there we go. Seems to be working, I think. Let's change that up. Add a H on the end. Happy. H at the end to differentiate. What has happened here? Yeah, that'll do it. Okay. Run the synthetic version. Oh, that looks quite similar, I think. That's pretty good. Yeah. So for the interaction, emotional condition is a little bit different. There still is a lot of overlap. But for the drug and emotional condition interaction, that is looking pretty good. And when we're looking at the actual statistics, there is a high confidence interval overlap. Not too shabby. I wonder if there's anything else that we could use. Yeah, so the observer ratings seem like a good example. Cool. So not only have I replicated the effect that's reported in the paper, as you would expect, I've also managed to create a synthetic dataset which doesn't necessarily give you the same statistical significance outcomes, but then again, a value of 0.05 is quite arbitrary, but it does get you very similar effect sizes. So the t-value here is 1.9, and the equivalent value here is 1.8. Gee, that's close. And the confidence interval overlap is quite good. So I think what it seems like is that this, you may not necessarily get the same statistical significance outcomes, but that's probably not as interesting as getting the same sort of outcomes when it comes to the estimated effect size and confidence interval. Nice. I'm happy with that. Okay. The next thing I'm going to try, I might regret this, is figuring out how to create introducing random missing data. So these models seem to be working quite well. But what happens? We have a look here. Yeah, there's a ton of missing data. Lots of missing data. That still does quite well. How about that? So for a lot of participants, they didn't seem to collect the data for the observer outcomes. But then looks like for about 2/3, that's a big data set. Well, relatively speaking, for oxytocin work. Okay, that's a really nice example. What else we got here? Let's look at here's the data. One thing that's missing is a code book. which makes it a little bit easier to actually understand what these variables mean. Yeah, there's all the missing stuff near the end. I wonder if there's anything else interesting that we can get out of this. Maybe if there's an effective gender. Let's go back to our script. Let's save it just in case. What does emotional condition mean? I want to look at that again. Nope. Ah, receiving help and control condition. So that was the emotional condition, I think. Oh, suspicious. I wonder if that drug guess. Oh, I want to know what this stuff is, because drug guess is quite interesting to see whether people given oxytocin can actually figure out what they've been administered. Is there... That's a different data set. So there's the outcome of the study. In sum, in the context of receiving help from a stranger, oxytocin administration fostered more positive, effective, and social responses. Interesting. Let's just for a bit of fun add in a gender effect. Having a three-way interaction is kind of underpowered for this, but I just want to see what it looks like. So what I'm going to have to do is what's it called? Gender, lowercase. Re-import the data. That. Double check that our gender comparison has worked. Waiting for the plotting to come up. Go to the next plot. That's pretty even. 0 and 1, not sure which is which, but that's quite similar. Make a synthetic dataset again. Ah, already done that. Redo happy with the additional sex interaction. Adding this is, yep, gender, gender, is that going to work? Yeah. Ah, there we go. Add the plus. So this is for the three-way interaction. Just want to see whether I can replicate this. Okay. Same p-value, 0.42, 0.4276. Yep. Gender plus gender. Yep. Let's compare the two. Nice. That's looking pretty good. So for that three-way interaction, if we were to run that, there seems to be considerable overlap with our synthesized and our observed data. Nice. I'm not sure if I'll use that example, but I was just curious to see what would happen there. Cool. All right. I am going to wrap up this section for now because I have some other writing to do for different projects. See you later.